So, just wrapping up the last two slides on the theorem that I've mentioned a number of times, the central theorem of hypothesis testing statistics, Central Limit Theorem. So everything we've done so far has been explained essentially by the Central Limit Theorem, which states, and I'm reiterating what I've said earlier, that given a population with mean mu and standard deviation sigma, the sampling distribution of the mean will have the following things under the Central Limit Theorem: a mean equal to mu, a standard deviation of the sampling distribution of the mean, which is known as the standard error of the mean, equal to sigma divided by root n, where n is the sample size. And it's guaranteed under the Central Limit Theorem that the distribution, the sampling distribution of the mean, will approach the normal distribution as n increases. And this is true for a wide range of distribution types in the population. It's guaranteed to be true for if the population data is normally distributed. So we saw this earlier. Here's an example. Here we take data from a dice which is not normally distributed, and we see that this is an individual sample of 100 throws, or we could do one of 25 throws, and we found in this example we take 5,000 samples of throwing dice, even as small samples of 25. The mean is very close to the theoretical mean of the population for a fair dice, 3.5, and the standard deviation is the value that statisticians have calculated. So this approximation of the sampling distribution of the mean to a normal distribution is true pretty much whatever the shape of the distribution of individual values, as long as n is not tiny. As long as it's certainly of the order of 25 or more, it tends to work out. So if the population is normal, the sampling distribution of the mean is normal for all n. If it's symmetrical and unimodal, like something that's not normal, like a dice distribution, it'll be normal for small n, and even for reasonably highly skewed distributions, it'll be normal when n is greater than 30. So often if our sample sizes are 30 or above, we don't have to worry too much about the normality of the data, because actually it isn't the normality of the raw data that we're concerned about, it's the normality of the sampling distribution of the mean. And that's the end of lecture 2. Thanks for listening.